Good afternoon, ma'am. Today I'm going to tackle about the basic role of operating system. An operating system is the most important software that runs on a computer. It manages the computer's memory and processes as well as all of its software and hardware. Also allows you to communicate with the computer without knowing how to speak the computer's language. Next one is the operating system, part of the computing system that manages all of the hardware and software. It also controls every file, every device, and every section of main memory and every nanosecond of its processing time. It also allows to controls who can use the system and how. Next one is the subsystem manager and their functions. Essential managers of an operating system are memory manager, processor manager, and device manager, and also the file manager. Each subsystem manager must perform the following tasks. First is to monitor its resources continuously, and it also enforces the policies that determine who gets what and how much. It also allocate and delocate the resource when it's appropriate. Next one is memory manager, in charge of main memory or RAM. Its functions is to preserve the space in main memory occupied by the operating system, checks the validity of each request for memory space, and it also sets up a table to keep track of who is using which section of memory in a multi-user environment, and delocates memory when the time comes to reclaim the memory. Next one is processor manager. It decides how to allocate the central processing unit or the CPU. There are two levels of responsibility to handle jobs as they enter the system. It's handled by jobs scheduler. And the last one is to manage each process within those jobs or handled by process scheduler. Next one is device manager. It monitors every device, channel, and control unit. Its functions are to choose the most efficient way to allocate all the system's devices, printers, terminals, disk drivers based on a scheduling policy. And it also makes the allocation, starts its operation, and last one is to delocates the device. Next one is the file manager. The file manager keeps track of every file in the system, including data files, assemblers, compilers, and application programs. And its functions is to enforce restrictions on who has access to which files by using predetermined access. And it also controls what users are allowed to do with files once they access them, and allocates the resource by opening the file and delocates it by closing the file. Next is types of machine hardware. So, essential hardware components include memory chips, input or output devices, storage devices, central processing unit or CPU, and there are also types of operating system. Operating system for computers fall into following categories. Each category it has batch, interactive, real-time, hybrid, and embedded. So let's tackle about batch systems. Batch systems relied on punched cards or tape for input in past, and its efficiency of the system was measured in throughput. Next is interactive systems. Gives a faster turnaround than batch systems but are slower than the real-time systems. So it introduced for users who needed fast turnaround when debugging their programs. And the operating system required to development and of time sharing of software. Next is the real-time systems. The real-time systems fastest and used in the time-critical environments. And real-time systems are used for space flights, airport, traffic control, high-speed firecraft, and industrial processes. And it also sophisticated medical equipment, distribution of electricity, telephone, switching. A real-time system must be 100% responsive 100% of the time. Next is hybrid systems. It's a combination of batch and interactive. It accepts and runs batch programs in the background when the interactive load is light. Next one is the embedded systems. So the embedded systems, computers placed inside other products to add features and capabilities. In the operating system with small kernel and flexible functions, capabilities will have potential in embedded system. Next one is the system architecture. So a system architecture is the conceptual model that defines the structure, behavior, and more views of a system. An architecture description is a formal description and representation of a system. It organized in a way that supports reasoning about the structures and behaviors of the system. And improvements in system architecture is that use of object-oriented design, and then also possibly to modify and customize pieces of an operating system without disrupting and integrity of the remainder of the system. And then it also makes software development groups more productive. And then the last one is it's limited to a few essential functions. So that's all, ma'am. Thank you for listening to my video.